I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Today I wanted to talk about other trig identities. There are several more trig identities you need to be familiar with. We don't use them all the time. The three Pythagorean identities I've seen on the ACT and the SAT test, all the reciprocal identities are usually needed on those tests. The rest of these, for instance, we have the double angle concept. If you need to know exactly what 37 degrees is, you pick up your calculator, you find the sine of 37, and you get a number. Back before we had calculators, when we had trig tables, and when we had slide rules, yes, I'm really that old, you needed many more of these trig identities. So I just want you to be familiar with them. This is other trig identities. It says I can memorize, prove, and use the symmetry identities. I can be familiar with and opposite angle identities. I can be familiar with the sum and difference identities. I can be familiar with the double angle identities, and I can be familiar with half angle identities. Like I said, we don't use these a lot. Originally, this is what my I can statement said, that I can memorize, prove, and use. But since we have modern day calculators, most people don't memorize, prove, or use these. There will be a time in your trig class in college where you will prove them, convert them, and have to memorize them. But right now, I just need you familiar with them. Once again, this video will go right here. I've given you some other videos. I've even given you a complete source of all the trig identities and how we got them and how you prove them. If you're interested, you can go down there. These are the symmetry identities. Most of you got this when we went to the unit circle. We went all the way around, that's 360. So what did a 720 angle look like? A 720 angle looked like a 360, which also looked like a zero angle. So A, sine of A plus 360 is the same thing as the sine of A. If you take the sine of 90 and you go all the way around and you come back, add 360 and you come back up here, 360 and 90 is 450, but it's going to look exactly like the sine of A. The sine of 90 and the sine of 450 are the same. Sine of A plus 2 pi, I put it over here in radians because you know that 2 pi is 360. So I just wrote them both in radians and in degrees. This is the opposite angle identities. The sine of minus 90 is the same thing as minus the sine of 90. The cosine of minus 70 is equal to minus the cosine of 70. Because in those negative quadrants, 4, you're going to have tangent down here in 3 is positive. Sine and cosine down there in the negatives are going to be negative. Once again, I just want you to be familiar with these. We're not going to use many of these in class, but I can prove all of them. And if you have one you think I can't prove, we'll work through it and see if we can prove it. These are called sum and difference identities. These are sum and difference identities. I've used the plus sign all the way through for the plus identities, the sum identities. But if you want to replace all my plus signs with a negative sign, that would be the difference identities. The sine of A plus B is equal to the sine of A times the cosine of B plus the cosine of A plus the sine of B. So for instance, if you want the sine of 60 plus 5, it would be the sine of 60, the cosine of 5, plus the cosine of 60 and the sine of 5. And you add all that together, and it's going to take me 6 or 7 minutes to work that in class. In the meantime, you people are hitting the TI-83 calculator, and you go sine 65, and you get an exact answer, just like I would with that equation. Tangent is of A plus B is equal to tangent of A plus tangent of B divided by 1 plus the tangent of A times the tangent of B. That is, its sum divided by its product plus 1. They're here. They're in your analysis book. I want you to be familiar with them. We're not going to spend hour after hour proving each of them. Pick one Friday, I'll prove it. Pick another one Monday, and we'll prove it. Here are the double angle identities. So if you have 60 degrees, and you already know what that is from the special triangles, and you need to know exactly what 120 is. The sine of 60 times 2 is equal to the 2 times the sine of 60 times the cosine of 60. It's much quicker for you to hit a scientific calculator and go 120 and hit the sine button. I realize these are slow, but in the old days when we had slide rules and pages of trig tables in the back of a math book, we needed these. And some older professors in college are still going to think you need these, and they're going to tell you to memorize them. And when they do, you know my advice, memorize them. These are the half angle identities. If you know what 30 is, and we do from the special triangles, then you can know what 15 is. So if you want the sine of 15, which is 30 divided by 2, it would be 1 minus the cosine of 30 divided by 2. If you want the cosine of 15, which is 30 divided by 2, it would be the square root of 1 minus the cosine of A divided by 2. And if you're going to put all that in your square root, many of you aren't going to bother. You're going to hit 15, hit the cosine key, and you're going to find out the exact value of the cosine of 15. I want you to be familiar with these. You're going to get to pick 2 each day, and I'm going to prove them for you. I'm going to give you a good example. I'm not going to make you do many of these in the book. One thing, they take pretty long. And 2, I'm not sure I want you working on them alone at home and getting confused. So we'll do a few in class. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.